Hey, FILO community. Thanks so much for joining us today. My name is Luke Roetman, and I am on the business development team at Clark. So I'm actually here with Alex Stave on our Clark team, and we are here together at Church of the Highlands Gadsden campus, where we had the opportunity to launch this just a few months ago. And when I started at Clark about a year and a half ago, lots of people would tell me what Alex did, and it was kind of funny because everybody had a different answer. So to quote Office Space, what would you say you do here?
I don't really know, but I get to help with the sales side. So figuring out solutions to people's problems, and then the commissioning and training side as well. So getting in kind of the nitty-gritty details of setting up the larger systems that we do, a lot of large-scale audio networks and things like that that'll work in program and commission and make sure that they work well.
That's awesome. So you kind of have your hand in almost every project, every step of the way.
Yeah, which I really enjoy. It keeps me learning and growing, and that's what I'm passionate about.
Okay, so there are lots of different ways for churches to get into transitioning out of kind of the whole analog infrastructure, transitioning into more of an IP infrastructure. We actually just did this fairly recently at Willow Creek, right?
Yeah, in the main room of Willow Creek, that's where they had an older audio system there, and we pulled out literal tons of cabling. So all the old analog splits, analog high lines, all those different things, and that's where we replaced it with a network-based system.
Awesome. So you took all of that analog stuff and sold it and went and got a really nice demo.
Yep.
All that copper.
A lot of copper right there. So again, it's kind of that shift from just having that strict infrastructure that only does one thing to now being able to do anything anywhere once it's on the network.
That's awesome. How do you separate the different platforms? Like, how do you separate a lighting, infrastructure versus audio versus video? What does that look like?
So the simplest way that we've done in the past is separate switches. And you see a lot of people do that for Dante. They'll do a separate switch for lighting, separate switch for streaming, separate switch for video and device control and things like that. And basically everything at this point on the market has some sort of network port on it for control at a minimum. And now we're moving to this shift where we're transporting media and other time-sensitive and critical things over the network, where we have different needs for that as well. So having a bunch of different switches for each different use in larger systems starts to become impractical. So that's where we use what's called Vlans to separate out that traffic.
Yeah.
And the reason why we want to separate that traffic out is A, for making a robust and stable network, where one part of the network, a change in that can't take down another part. And then the other reason is to separate the traffic from affecting other devices. So a lot of times when I go into church, that's where they'll have a lot of things on their production network and they won't know why things aren't responding well, or things are kind of glitchy, or web pages don't come up quickly on devices. And that usually relates to the way that you segment that network. And we'll talk a little bit later about unicast versus multicast traffic and creating those broadcast domains that help manage those things.
Yeah. Before we get into that, though, it sounds expensive, right? I mean, what about the smaller church that wants to get into this? They don't have an IT team, that can help manage all of that. Start thinking about VLANs, maybe production guys that aren't as familiar with, incorporating those. Tell me about that. Is it expensive? Is there options? Like, do we always have to hire somebody to kind of manage all of that? What does that look like?
So now that we're at kind of a mature point with a lot of this production network technology, there are some easy options from certain manufacturers like Luminix. Netgear has some really easy one-touch configuration switches where they're already preset with profiles for different things like Dante or Qlan or AVB, that you don't have to set that up, all the parameters and details yourself at that point.
Okay, so to dive a little bit deeper into networking and a lot of the different platforms and stuff you can use, we kind of need to understand a little bit of the basics, right? Some of the nomenclature of IT networking, terms like multicast, unicast. Can you explain that a little bit?
Yeah, so we have a couple different types of traffic on the network. That's where when you send a data packet on the network, it can either be one-to-one, like you're mailing a letter. It can be one-to-many, where basically everything is receiving that on the network, or it can be one-to-all, which is broadcast traffic, where it's just going everywhere. So the way that we segment our networks are to manage that multicast and broadcast traffic. Because one-to-one traffic is easy on a network. It's not a huge load on things overall. It's when you, as something that's receiving data on the network, is receiving all of these extraneous signals that you don't want and have to process through that. That's when things can start acting slow and things can start having issues, and you can start to have problems. So that's kind of the reason for subdividing those.
Got it. Is that hard to manage? You talked earlier about setting up a VLAN and how that can actually be more simple with some of the equipment and options that are out there.
Yeah, so setting up a VLAN is basically creating what's called a broadcast domain. And within your VLAN, that's where your broadcast traffic is limited just to that VLAN. Now, there's ways to route multicast and broadcast traffic between VLANs, but generally you don't have to do anything like that. And segmenting that is the easiest way to keep your network stable and to not have that extraneous data going to all of the different devices on your network. So we normally segment a network into a few kind of logical sections. That's where we have device control. So this is kind of your basic networking that we've had since the early 2000s. That's where I want to be able to control my mixer on my iPad. I want control and remote monitoring of all my devices. That basic stuff is where we keep that isolated into its own VLAN, which we then usually tie in with the house IT side, so that way you can get to that over your Wi-Fi access point and wirelessly connect through the building. And then as a multi-campus church, I can jump on and support another campus and troubleshoot something remotely, and I don't have to be there to do that. So we start with that, and then we move to kind of our other specific VLANs or broadcast domains that we have. And the first is going to be our audio transport. So that's Dante, that's AES67, that's QLAN, and there's a few other different protocols, AVB, and that's where we make that a separate VLAN as well, because there we have clock data, which is multicast, and keeping that everything in sync is going to be the tricky part with that when you merge different protocols, but we leave that as an isolated thing, and that we normally don't tie with the house network.
Gotcha. But can those protocols live on the same VLAN? So if you have a Dante system and a QLAN system, can they live on the same VLAN?
So those can absolutely live on the same VLAN. There's a few settings when you deploy, for example, a Qsys system that can make it compatible with the same QoS settings as a Dante system. But you can definitely do that. And it dives into some more advanced things with clocking. You have different forms of PTP on a network, but it's absolutely doable, and we do that regularly as long as you're doing it in an intentional way.
Gotcha. Any other terms that you feel like would be good for people to understand before we kind of dive into looking at some real world examples and even talking more about the audio side of it? No. Great. So at this campus, there are a variety of things going on the network, right? We have a bunch of audio, lighting, video stuff, but even with audio, there's a lot of different networking protocols that are existing on the same converged network, right?
Yeah, and that's where this is a great case of designing a system for the future that's really flexible, but at the same time, because we have all this technology available and it's at a mature point, it's extremely cost effective when you start to consolidate things and leverage that flexible infrastructure.
It's awesome. And relatively simple, right? As complicated as it sounds, it was not. You just said it wasn't very expensive, but was it complicated to kind of get up and running?
No, and that's where, again, the initial configuration, as long as you set that network up and break it into logical segments, that's where it ends up being very stable and easy to use. In this case, we use some Cisco switches, which do require a little bit more configuration and programming. But again, you could use some of those easier options that we mentioned earlier.
Yeah. Now, I know we'll get a chance to see it in a little bit, but tell me what all is going on the kind of production network.
So here we have streaming video from the main campus using some Fujitsu encoders. We also have all of the audio is over Dante, and then we have QLAN audio as well for distributed audio throughout the building. We also have device control. So that's where, again, every device is accessible not only here, but I can pull up panels on my iPad, or you can access it from any of their campuses around Alabama.
That's awesome.
And to do that, that's where that was a partnership of not only having a separate production network for the things that need to be stable, but we are tying in with their house IT department to do a lot of those things.
Very cool.
We're here now in the rack room here at this Highlands campus, and that's where you can see that the way that we design systems has changed quite a bit in the emphasis of what our connection types are and the way that our racks look. And that's where in here, we see that the primary focus where all of our connections are actually our network switches. So we have most of our equipment is all either transporting media over the network or we're controlling it over the network, and you see that reflected here. So just to kind of walk through what we have our general production switches here in the rack, and we have them divided up into VLANs, which we talked about earlier. Our first VLAN that we have section of the network would be our audio transport, and that's where with that we're transporting audio over Dante, AES67, and QLAN, and that's all color-coded with these blue cables here on the network switch. The thing that you have to be careful with when you're mixing multiple different protocols on the same network is your clocking. And the type of clocking that we use on a network is not word clock like what we used to use in the past, but it's called PTP, or Precision Time Protocol. And there's actually a few different versions of PTP depending on the audio protocol that you use. Dante uses PTP v1, whereas AES67 and SMPTE 2110 use PTP v2, which has a few different media profiles within that as well. And then you have AVB that uses another form of PTP. So when you're adding all these different things on the network, that's where you have to make sure that A, are they compatible, and B, can you clock them all together? So in this case, we have one device acting as both the PTP v1 master for all the ordinate stuff, as well as the PTP v2 master for the QLAN and AES67 streams that we're using. So we have our blue cables, which are our Dante network, and then we also have the red cables, which are our redundant audio transport network. And one thing that most network streaming media protocols allow for is true redundancy, which we didn't have in the past. So that's where, again, you can have a cable failure, you can have a switch failure, things like that, and you can still pass audio. Whether it's seamless switching with Dante or you have hitless switching with video as well. This allows you that next level of redundancy so that when things go wrong, your service can still happen and you might not even know that anything failed or stopped working. The next part of the network that we want to look at are going to be our general production network for device control. And that's where, this is where all of your iMac computers, ProPresenter machines, your mixer for iPad control, all of that stuff generally lives on our device control VLAN. And with that VLAN, that's where we usually tie in with our house network. And that allows us to have access to the outside internet, as well as we usually ask for a hidden SSID over the building Wi-Fi, so then we can remotely access any of our devices that way. In a multi-campus setting, that's where coordinating with your IT department allows you to manage any campus from anywhere. So here at Highlands, I can actually get on and see devices at other campuses across the state of Alabama from anywhere. And there's different monitoring programs that allow you to see status of devices and things like that, and have the ability from a centralized location to proactively respond to things when things go down and things fail, to be alerted right away to those issues. The last thing that we have here is going to be our lighting network, and that's where here it's isolated on a path port switch, and that could be also on a Cisco switch or anything else like that. The guys here at Highlands just prefer the pathway switches because they add a little bit more control and have a really nice visual interface to do that. So one thing I want to touch on when we're talking about production and show networks is routing between networks. So one really nice thing about what we do in the production world is that for the most part, we don't have to worry about routing between other subnets or other domains or parts of the network. So you have your OSI model, which kind of defines your layers of networking. And layer 3 is where we get into routing and switching, and we live for the most part in layer 2. So that allows us some kind of reliability and redundancy in that our networks are pretty simple for the most part. So when we talk about dividing up the network where we tie in with the house IT side for our device control and routing and things like that, For the most part, our audio transport and a lot of our video transport stuff is not tied in with that house network. So it lives in its own kind of isolated world, and that allows for a lot of stability in what we do in reliability. And again, goes back to dividing the network up into different segments that make sense and make for a robust infrastructure. So kind of working our way through equipment here, we have our streaming equipment, and that's where we have a Fujitsu decoder here. There's many different options for doing streaming between sites. You can use devices that stream over the public internet, like Resi, or you can do stuff where you have direct connection between sites using MPLS or VPLS or something like that. And that's what they do here at Highlands with the Fujitsu encoders and decoders. The main things to look for on those VLANs, you want to prioritize that traffic over everything else in the building. So that way, if you're streaming out to the general internet, that traffic is prioritized out, or if you're streaming between sites, that traffic is prioritized as well over other things, so you can have a stable and reliable experience. A lot of the new technologies with resilient streaming with Resi and things like that allow you a lot more leeway in what you do, and you can use a lot more unstable connections when streaming to the web. But again, it's good to, from the forefront, design your systems in the most reliable and robust way possible. The next thing we have here, we have a FILO for both recording and then confidence streaming of the service back to their central management and monitoring location. And then we still do have SDI video because that's the most cost-effective way to transport broadcast quality video at this point in time. But you'll see more and more video moving over to broadcast network-based video protocols. One thing we do see a lot right now is replacing our building distribution with video over IP. So we're using a lot of stuff from either SVSI, Crestron, Visionary Solutions to put decoders behind all of our TVs, and then that allows us to route anything to any display in the building. And it's come to a point where that's a very cost-effective way to do it, and adds that flexibility of that anything anywhere approach that a modern system design allows us to do. Lastly, we have our audio rack here, and our audio infrastructure again is all network based. All of our sends from our wireless mics are over the network. We have some analog outputs that feed our in-ear transmitters. And then a big thing that we have here is actually the Qsys Core. And this core provides DSP processing for a lot of the building, as well as we're doing simple device control with that. And simplifying things that we'll see with touch panels in the future allows things to be a lot easier for volunteer operators, as well as streamlines your workflow on the weekend. So with kind of a flexible device like this, that's where you can automate a lot of those behind the scenes things. Like submixing intercom inputs for the band and things like that in a multi-campus setting that you want, but you don't necessarily want your volunteer to have to deal with those things. And then lastly, we have our PA amps, which are fed off of feeds from the network, and then we have device control as well for that. So one of the things with shifting our mindset of how we design systems that moving to a network-based architecture has allowed is making it a lot easier for doing upgrades in the future and swapping pieces of equipment in our racks. So that's where one of the key things that we do here, we just have a bunch of network ties in the top of the rack, and then if you need to swap out a device in the future, you're literally just popping that device out, popping a new one in, hooking up power and network, and you're good to go. So moving on to the control room here, that's where we can see a few different uses of our production network and kind of cool things and flexibility that allows in kind of your normal church campus environment. One of those things that we like to leverage here, again, talking about our audio network, that's where on the back of our machines, for example, our Resolume computer, we have AVIO interface to strip audio off of that. We still use traditional embedders and de-embedders, and we're actually using a lot of Dante throwdown embedders and de-embedders, as well as card embedders and de-embedders. But having those little AVIO boxes that we can plug in via USB and get audio from a machine to the production network makes it super simple and easy to add things in the future and change things around. Another thing that gets used a lot is on the control side. That's where we've seen kind of the influence of having cheap control surfaces like stream decks. In this case, it's being used to control Resolume and ProPresenter and a few other things, as well as our Qsys panel that we'll get to in a second that allows for additional control for audio routing and other sources like that. One thing that gets used now as kind of a tool is called NDI. And it's not really a broadcast streaming protocol, but it gets used for certain functions in cool ways. And in this case, we're using it to stream our lyrics from our ProPresenter machine and send that over the network to Resolume to basically overlay our lyrics on the LED wall in an easy way. And those are kind of some of the features when you have everything set up on the network. Sharing resources, you can send things to and from devices super easily. So coming over here, one thing that we leverage in this setup a lot is the Qsys system for control. And Qsys is basically a flexible DSP system that also allows you simple device control. For a lot more complex automation and things like that, that's where we still use traditional Crestron and AMX systems. But in the church world, that's where Qsys allows technical staff to make changes to control panel layouts and things and really customize it to what really works for the church that you're in. Here at Highlands, they're utilizing it for a bunch of different things. And in our control room, we can see that it's providing both our source selection for all of our monitoring. We can pull up any of our feeds to monitor the audio by selecting them on the Qsys panel, as well as it's allowing us some additional flexibility with a standard party line comm system to add some routing, to add in program audio, to mix in the MD or music director and click and guides for our lyrics operator. So we're adding a lot of flexibility without adding a lot of cost because again, we're sharing resources from the core that we saw in the back rack room. So here, we're not only doing our booth monitoring, we also have control over all of our distributed audio. We're actually playing back audio as well from that core, is hosting some audio files and playing that for background music. And then we've integrated our audio routing for embedders, house light control, and then there's also some tools that the Highlands guys have actually added on since we left to generate time code for testing and things like that. So that's where, with some of these things, they morph over time, and they're easy enough that technical staff can make those changes themselves. So one of the benefits that we see of this new kind of philosophy behind designing systems is that things are a lot more flexible, but they end up costing less in the end. Before, we used to do a lot of analog ties and analog subsnakes and things like that throughout a building, which those add up pretty quickly. And in this case, we just have a couple of network ties on the upstage wall. And then one cool thing that's kind of specific here to Highlands is that they use these portable racks on the stage that contain everything that's needed for a service. So the reason they do these is that they start out at a portable campus using the same system, and then when they move to a permanent site, that's where they can just roll these in, plug them in, and they're good to go. And these racks, again, have a primary and redundant network connection in the back that go to a pair of network switches here that then allow us to plug in all of our devices on the stage. So we both have our analog inputs, so all our normal sources, guitars, keys, those sort of things. And then we have our monitoring, which is here using Avioms that are getting fed Dante from the network. The cool part about this being a self-contained rack, again, is that everything fits in there. So there's direct boxes in here, there's the keys and tracks, devices, all that stuff lives in a really compact rack that just has your network connections on the back, and that's it. So one thing I want to touch on here that we actually saw earlier on, again, was that flexible Qsys Core to do some of the behind-the-scenes audio processing. And having volunteer operators every weekend, it's a great thing to be able to simplify a lot of those things. For example, one of the things that we do a lot is routing of intercom to the band's ears. So whether you have click and tracks and stuff from your main campus that are coming to satellite locations, or you have talkbacks from different positions around the room, being able to submix those behind the scenes in Qsys, and then just have a single flow into your audio console from that simplifies it for the end user and makes it easier for everybody. So we're here on the kids wing side of the building, and you'll see that again, our rack basically looks like a network rack. All of our devices, whether it's transporting audio, transporting video, or different things like that, are plugging into our network switches here. And again, we see our similar color code to make it easy. We have blue is our audio transport. We have some gray cables, which is general device control. And then we have our red, which is our redundant audio transport network over here. We have our fiber that connects this area back to that main rack room where our main DSP core is that we're using resources from, as well as our connection to the house IT network and things like that. So in this rack, there's no actual audio processing happening. We just have some amplifiers that provide us with additional inputs as well as our outputs to the speakers. So we're here in one of the kid spaces here, and that's where we can see that it's a very simple experience for volunteers walking in, which is what you want. You want them to be able to execute what they need to on the weekend without any stress of trying to figure out complicated systems. So in this space, we are controlling everything from the Qsys touch panel in this room, and that's where we have the ability to power on and off our devices. We have the ability to mix the microphone levels, the level of the computer in here, and we also have the ability to switch video sources. And to do that, we're using some network devices to get things on and off the network, and we have some wall panels to get audio in certain locations, and then besides that, we just have general purpose network ties, so you can add stuff in the future, and it's flexible to do so. But again, because we're sharing resources that centralize processing core between a bunch of spaces, it's honestly the same cost as doing a small or mid-size analog mixer and the way that you would normally do a kid space like this.
Well, as you guys can tell, there's a lot of different ways to do this. And that's just kind of one example that we just saw. So thanks again to Church of the Highlands for allowing us to come in and do this. Us at Clark would love to talk with you guys. If there's ever any questions we can answer in any way we can help, please feel free to give us a call, shoot us an email. Alex, thanks so much for joining us. Thanks for kind of giving us that tour. Anything else you'd like to add?
Yeah, I think the main thing today for us was to kind of give you guys an overall idea of how to structure a production network and how to break things up so that way you can build a stable and effective network moving forward. We're only going to see things move on to network-based architectures more and more in the next 5 years, even from where we are today. So that's why it's an important skill to definitely have and definitely dig in and learn a little bit in our roles as production people in church.
That's awesome. Well, there's a lot of great breakouts here, so we'll see you guys in the other rooms. Thanks so much for joining us. If we can ever help answer any questions, let us know. Call, email us. We'd love to help.